Hello everyone. In this video, we are going to discuss the solutions to the problem of the contest Codeforces round 847 Div 3. So the problem is that Polycarp was told at school that the number pi is irrational. Therefore, it has infinite number of digits in its decimal notation. He wanted to prepare for the day of number pi by memorizing this number as accurately as possible. So basically, we are given a number and we have to find from starting to till which point it is like the number pi. So a number pi for digit 30 look like this. So it has digit from 314 till the 27. So we have to find the maximum prefix which is the number pi. In the case 000, the first digit itself is not equal to 3, so it is 0. And the last test case which has all the numbers equal to the pi, that's why it's written 30. So the logic is pretty easy. We just have to implement a for loop where we have to make two pointers, one pointing to the number pi of the string. Here I have created a string which has size 30 going from 3 to 7, and I have taken input as a string and created a pointer j which will point to the first index of the string s, and I have applied a for loop and I have checked whether the particular ith digit is equal to the input string or not. If it is same, then I am incrementing both the counter and incrementing the length we have get till now, and otherwise we are breaking the loop and we are returning the number of prefix digit that are matched. This was the first question. Moving on to the next one. So this was somewhat tough, I guess, for non-mathematical students because the solution has to be include some basic maths algebra. So what we have given is we have given n six-sided dice, and each dice is marked a number from 1 to 6, and the SCR roll all n dice at the same time, and she get all the values from A1 to AN, but the Asia pet cat steals exactly one dice with maximum value AI and calculates the sum of value on the remaining n minus 1 dice, which is equal to R. So basically, you are given n, the number of dice, and the value of S and R. So we have to uh, output n numbers, the value which Tosia will get at output, which will have the maximum value as S, and the remaining will have the no, its sum should be S, I think. Yeah, the sum of sequence should be equal to S, and after uh, removing the S, removing the maximum value, it should be R. So I will describe you here better. Suppose we have n numbers A1, A2 to An, and suppose we sort this number, sort A. After we will get like A1, A2, A3 to An, right? So here we know the max will be An and the minimum will be A1, right? So here it is given that the sum is equal to n. So A1 plus A2 plus A3 up to An should be equal to S. Okay. And the maximum value, after removing the maximum value, it should be R. So we know that maximum value of An, then it is pretty obvious that A1 plus A2 plus A3 up to An minus 1 should be equal to R, right? So from equation 1 and 2 we will get that an will be equal to s minus r. So the maximum value which the SCR is removing has the value s minus r. So all the values apart from this maximum value should be less than or equal to s minus r, right? So what we can do, we can run brute forcefully a recursive solution because the number n is less up to 50 only. So what we can do, we will first assign the largest value as s minus r, and we can run a for loop till where the next value can go. I will open my solution to, okay, so I have taken n, s and r as input and then run a recursive solution. So it will go from I is equal to 1 to n. So for, we know that the maximum value can be equal to s minus r. So I have given in the s as s minus r. So it will go from s to 1. So in each case where x is going from x is going from s to 1, we are checking whether it is possible that if we put x as particular position, then it is satisfying the required condition or not. I will tell you how this equation has come, this particular if equation. See, we are given, suppose, these numbers, and the last one we know it is surely s minus r. So we have to find this n minus 1 number. We know the nth number will be s minus r, right? Okay. So what we can do, we are at first position. So we know that the maximum value it can attain is s minus r. Okay. So what if we assign the value s minus r to the first place? Then see, the all the numbers from 1 to n minus 1 should have sum equal to r, right? And if we assign x to this particular position, then this sum should be equal to r minus x, right? Then what can be the base case, like what will be the minimum value it can have? It will have minimum value when all these numbers will be equal to ones, right? So after assigning x, the remaining value from 1 to n minus 1 should be greater than or equal to how many digits are there? See, from first digit to the last digit it is n minus 1, and if we ignore this particular digit then it will be n minus 1 minus I, right? This is the number of digit after that particular ith position and before the last position, right? So it can have a minimum value of n minus 1 minus I. And what's the maximum value it can have? It can have maximum value when all these are assigned 6, right? So maximum value should be, sorry, maximum value can be always less than or equal to n minus 1 minus I. These are number of uh, places which are left, and each can have maximum value 6. So we can uh, see from this equation that if we assign particular value x to this place, and then if what we are getting as uh, the remaining sum is lying between these two numbers or not, that's what I am checking. See, wait a minute. See, this from first digit to the nth minus 1th digit, the sum we required is r, right? and if we assign x to this particular position, the sum which has remained to assign is r minus x. So this is uh, the sum which we are trying to given to this particular subarray, and we are checking whether it is lying between n minus 1 minus I. This is the lower bound, and it is should be less than equal to n minus 1 minus I. If it is satisfying this equation, then we are just push inserting that particular element in our answer, which is initially declared in globally, and then we are moving to the next position, and we are changing the value of r, because here we the value was r and then we have assigned x, so the remaining sum which we want will be r minus x, right? In this particular recursive solution it will work nicely. That was the solution to problem B. Let's move to the problem C now. So in problem C we are given a permutation, and what Christiana has done, she has she wrote it on a whiteboard and time in such a way that writing all the permutation at time, she skipped the pith element. Right? Suppose the permutation was 4213 of length 4. In the first sequence or first time, she will ignore the fourth element. Okay, so first she will ignore the 4, then this is the formulation she will get, then she will ignore 2, she will get a sequence like this, and when she will ignore 1, she will get sequence like this, when she will ignore 3, she will get sequence like this. All right, now what she has done, she has mixed all the sequence that she has get, that n sequence, and what we have to find what is the particular uh, we have to reconstruct the original permutation from this jumbled sequence. Okay, so suppose we have given the four sequence that are jumbled as 421, 423, 213, and 413. So there should be a sequence which has a first digit missing. I will show you here, it will be pretty clear from here. So if she has sequence as 4, 2, and 1, then 4, 2, and 3, then 2, 1, and 3, then 4, 1, and 3, right? Then we know that there will be only one sequence which doesn't have the 4 in the first place, that is the sequence number 3. So we know that if it has 4 in the first place, then it should be start from here, because it has something in this position, right? Okay, so now we can print 4. After that we will go to this particular column and we'll see which particular uh, number has only frequency 1. This will be the incorrect position, and otherwise the numbers which has frequency of n minus 1, that will be the original permutation. Afterwards we will increment this particular position. Now we will see which number has frequency n minus 1. We can see number 1 has frequency n minus 1, so we will print 1, and this was incorrect position. We will increment this. Now we can see that 3 has its correct position, so we will print 3. In answer we also can see that this is the correct permutation, 4, 2, 1, and 3. So it's also a basic question, we just have to good implementation skills for solving this problem. What I have done is created a vector and has taken all the inputs. After that, I have initialized a vector done, which will show that whether the particular ith sequence has moved to right or not. Like in the first place, this particular sequence was shifted to right, so I will assign done to the third sequence as 1, because what we have to do after we have shifted this particular sequence to right, we have to move the jth pointer to left. Like if we are traversing to this particular column, then we have to use the left of that particular position, right? So that will be done by this done vector, and I am running a loop from j is equal to 0 to n minus 1, and I am just counting the frequency. So the one which will have frequency as n minus 1 will be our the correct permutation place, and I will print that b. Okay, and then I am assigning done is equal to minus 1, because we have to get the previous column's value of that particular sequence, and it will run from 0 to n minus 1 only, but there are n numbers, so I have initialized a vector last. So what will be the last position, and whatever we have find till now will be initialized to 1 in the last vector, and which is not initialized till the end, we will print that. This was the solution to the problem C. Let's move to problem D. Problem D was really nice problem. I really like it. Okay. In problem D, what we are given? We are given a sequence of numbers from of n numbers from 1 to 10 to the power 9, and we have to create another sequence which will be a continuous sequence starting from any number, right? Let's say we have a sequence like, we will choose this sequence. So if we have this sequence, we can make a sequence like 5, 6. There is no 7, so it will break. So we can make another sequence as 5, 6 is done. Starting from 8 and 9, this is a continuous sequence, right? After that, a sequence can be 11 and 12. It is a continuous sequence. Then it can be 14 and 15, right? All numbers are 4 to the 8 numbers are there, right? So number of sequence will be 4. We can't get less sequence than this, because for having this sequence to form a single sequence, there should be a number 7, so that all the numbers can be contiguous. So initially what we can do, we can sort all the elements. After sorting, it will look like 5, 6, 8, 9, 11, 12, 14 and 15, and we will create a map which will store which number we have previously on a set. Like the loop will run from 0 to n, and we will see there a particular number 4, for which we will assign 5 to that particular sequence. Initially there is no number 4, then we have to create a new sequence starting from 5. Okay, now we will go to 6. We will find whether there is a particular sequence which has a number 5 in the last position. Yes, you can say that yes, there is a number sequence which has 5 in its last place, so we can assign this 6 to this particular sequence, and the last number to this particular sequence will be updated to 6 from 5. Similarly, this 7, we will start and go to this 7. We will see whether there is a, it is 8, sorry. We will see whether there is a particular sequence starting from 7. No, sorry, it's ending from 7. So there is no sequence. So we have to create a new sequence here starting from 8, and similarly it will go like 9 and then 11, 12 and then 14 and 15, right? So after that we will see how much sequence are there, and this will be our greedy approach, and it will surely maintain that this is the minimum number of possible sequence which can have all the contiguous numbers. So for implementing this, we can use a map which will store which is the last number till now. We will store the last element in its key, and the number of last element will be its value. So first we are checking whether the number previous than this particular number is present or not. If it's present, then we will decrement the frequency of the last element and we will increment the current frequency, because the number of last element will be this particular number. Otherwise, we have to create a new set which will have the current frequency, and then we will count how many numbers are there, means how many sequences are there, and then we will return that particular sequence. So this is all about the contest, and I hope you all guys like these solutions. If you like all these solutions, please press the subscribe button. I will further post all the Codeforces contest solution in this channel. Thank you.